Providing oxygen to astronauts is one heck of a challenge. There are major breakthroughs on the horizon for crewed expeditions to distant planets if magnetism outperforms our current techniques. Future astronauts will be able to create oxygen from magnets thanks to scientific advancements. Yep, that's right. University of Warwick researchers have used magnets to create oxygen for astronauts. Find out more ahead. First up, tell us how we can breathe with no air. Jordan Sparks was onto something. Maintaining the oxygen supply may be the most difficult of all things necessary for future journeys to Mars or beyond. After all, if other components of a mission fail, you may have days to correct them, but it's a matter of seconds. As a result, the International Space Station's production of oxygen is one of the more expensive and difficult aspects of a process that's known for not being cheap or easy. Gas bubbles remain floating in the water because there's no gravity to separate the liquids from the gases. Centrifuges, which are used by the ISS to generate what is frequently referred to as artificial gravity, take up a lot of room, energy, and maintenance resources to run. Countless different techniques, from springs to ultrasonic standing waves, have been tested. Some have been tried despite their very obvious drawbacks, such as shooting rockets. While other methods appear to work momentarily, they're not dependable in the long term. An electrolytic cell divides water into hydrogen and oxygen on the International Space Station, but you then have to remove those gases from the system. According to a relatively recent analysis by a researcher at NASA Ames, using the same design for a mission to Mars would result in such enormous mass and reliability costs that it wouldn't be practical to employ. Scientists knew that if that trip to Mars was to happen, they'd need to put their thinking caps on for something solid, and we might just have something. A worldwide team of scientists, including those from the University of Warwick, developed a method for converting water into oxygen in zero-gravity space. While the International Space Station astronauts breathe oxygen produced through the electrolysis of water into hydrogen and oxygen, this technique would not be appropriate for interplanetary spaceflight. At the moment, NASA relies on centrifuges to provide oxygen in space, but the machines are big and need a lot of power. Scientists have discovered that magnets can more practically create the same effects. Wait, what? Magnets? This was tested in a facility that simulates microgravity conditions at the Center for Applied Space Technology and Microgravity in Germany. The utilization of this incredible drop tower in Germany gave actual proof that this concept will perform in the zero-G space environment. After years of analytical and computational research, researchers used a technique to detach gas bubbles from electrode surfaces in microgravity settings, created for 9.2 seconds at the Bremen drop tower. Basically, research demonstrated for the first time that gas bubbles can be attracted to and repelled from a simple magnet in microgravity by submerging them in different kinds of aqueous solutions. The study's novel method demonstrates that magnets can be used to carry out the same process. Since the early space flights in the 1960s, efficient phase separation in lower gravity settings has been recognized as a barrier to human space travel. As oxygen for the crew is created in water electrolyzer systems and requires separation from the electrode and liquid electrolyte, this phenomenon poses a unique difficulty for the life support systems on board spacecraft and the International Space Station. These effects suggest that even in the near absence of the buoyant force, efficient oxygen and, for example, hydrogen production in water electrolyzer systems can be achieved. This has significant implications for the further development of phase separation systems, which is exactly what's needed for long-term space missions. So, how was this discovered? The scientists didn't just decide to drop magnets from the tower based on pure assumption. The crew had spent years studying the theory before they felt ready to put it to the test. They had even proven the viability of related concepts 4 years prior, but in that instance, they could only make them function with a particular mix of solution and nanostructured cells. The production of oxygen for breathing on lengthy space trips, as well as possibly hydrogen for fuel, is most likely the most significant application. And it might not just be used for that. It'll also enable the separation of a variety of gases and liquids, which could help in things like recycling dirty water and removing CO2 from the air. Scientists investigated this phenomenon in olive oil, air bubbles and ultra-pure water, a chemical solution, a broth used to grow bacteria, and air bubbles and ultra-pure water. Like, you name it. The separation was always present, but was less apparent as viscosity increased due to a drag effect. Even in earthly conditions, magnetic fields have been found to accelerate and improve electrolysis. Next, let's see why this is such a breakthrough for astronauts. Long-duration space flights have a number of negative effects on the human body, and recent research indicates that astronauts' blood is altered as a result. A study found that astronauts' bodies are consuming their own blood cells more quickly in space than they are on Earth. Since the first space flights, astronauts have routinely reported having space anemia when they return to Earth, but we didn't know why. The study demonstrates that more red blood cells are damaged upon entering space, and this process persists throughout the astronaut's journey. Space anemia was previously believed to be a temporary adoption of the human body, but this study shows the effects endure for at least a year after returning, because hemoglobin, a particular protein found in red blood cells, is responsible for transporting oxygen from the lungs to the rest of the body. A decline in red blood cell levels is alarming. Anemia, a condition where oxygen cannot reach the body's tissue and leaves a person feeling exhausted and weak, can result from a shortage of red blood cells. Before their 6-month tenure on the International Space Station, researchers took blood and breath samples from 14 astronauts for study. It was also collected from the astronauts up to a year following their journey. According to the findings, astronauts lost over 54% more red blood cells in space. Can you believe that? Just to give you an idea, our bodies produce and eliminate about 2 million red blood cells per second while while we're on Earth. But throughout their 6-month trips, astronauts lose 3 million red blood cells each second. According to scientists, red blood cells are being damaged as a result of fluid changes that astronauts' bodies go through to adjust to and from their weightless environment. Thankfully, because your body is weightless, having fewer red blood cells in space is not a huge concern. What's concerning is that this condition doesn't go away for months after coming back. This shows us why the discovery of producing oxygen from magnets is a huge step forward in making space travel a safe option, especially for astronauts. Now, in other news from space. First up, SpaceX cargo postponed as a result of poor weather, including a high probability of precipitation at the splashdown sites. NASA and SpaceX have decided to postpone the Thursday, August 18th undocking of a SpaceX Dragon cargo resupply spacecraft from the International Space Station. On Friday, August the 19th at 11:05 a.m. Eastern Standard, mission teams now plan to separate the Dragon spacecraft from the space station. Starting at 10:45 a.m. Eastern Standard, NASA will broadcast coverage of Dragon's undocking and departure on NASA television, the NASA app, and the organization's website. On Saturday, August the 20th, the spacecraft will make a parachute-assisted splashdown off the coast of Florida after returning to Earth's atmosphere. Next, Java's got a hand in that. You know those telescope pictures of space you really liked? Yep, the beautiful photographs of the James Webb Space Telescope has been sending back to Earth appear to have been produced with JavaScript, the computer language about which web developers and consumers complain all the time. We don't mean that in a snide way, like that NASA hosts them on a website that uses JavaScript. We're referring to the fact that JavaScript files play a significant role in the real telescope, possibly one of humanity's greatest scientific achievements. Oh, and it was created with a 2002 software development kit. The fact that they use such antiquated technology then seems a little weird. You know when the last update was? Almost 20 years ago! Meh, as long as it works and we can see more of those breathtaking photos. And lastly, we're finally breaking boundaries in space. NASA will launch a fresh crew into space the following month. What's so great about it is that a Native American woman will be traveling on board for the first time. As mission commander, astronaut Nicole Anapumana, the Wolaki of the Round Valley Indian tribes, will be in charge of all aspects of flight. It's crucial that we share this with our community so that the other natives, especially the kids, can see that some of the existing boundaries are actually starting to break. On the Crew 5 mission, Miss Mon will go to the International Space Station on the SpaceX Dragon spacecraft with 3 of her co-workers on September 29th. Hope she has better luck than Matt Damon's Dr. Mon. That's a wrap for this video. After this discovery, do you think that there are any other hurdles left for long-term space travel? Let us know in the comments below. As always, don't forget to like this video and subscribe to our channel for more videos like this. See you in the next one.